The Aditya-l1.
It is the first Indian mission to study the Sun. It is planned to be launched by April 2020. It was conceptualized in 2008. Initially it was envisaged as low-Earth orbiting satellite with a coronagraph to study solar corona. Now the project has been expanded and is now planned to be placed at Lagrangian point L1. Thus this mission was renamed as Aditya-l1. The mission has been allocated 378.53 crores, $53 million. Approximately it will be inserted into the halo orbit around L1 point, which is about 1.5 million km from Earth. What is Lagrangian point? Lagrange points are positions in space where the gravitational forces of a two-body system like the Sun and the Earth produce enhanced regions of attraction and repulsion. These can be used by spacecraft to reduce fuel consumption needed to remain in position. There are 5 special points where a small mass can orbit in a constant pattern with 2 larger masses. The Lagrange points are positions where the gravitational pull of 2 large masses precisely equals the centripetal force required for a small object to move with them. Of the 5 Lagrange points, 3 are unstable and 2 are stable. The unstable Lagrange points, labeled L1, L2 and L3, lie along the line connecting the 2 large masses. The stable Lagrange points, labeled L4 and L5, form the apex of 2 equilateral triangles that have the large masses at their vertices. L4 leads the orbit of Earth and L5 follows. The L1 point of the Earth-Sun system affords an uninterrupted view of the Sun. An object that orbits the Sun more closely than Earth would normally have a shorter orbital period than Earth. But that ignores the effect of Earth's own gravitational pull. If the object is directly between Earth and the Sun, then Earth's gravity counteracts some of the Sun's pull on the object, and therefore increases the orbital period of the object. The closer to Earth the object is, the greater this effect is. At the L1 point, the orbital period of the object becomes exactly equal to Earth's orbital period.
This is an example of spacecraft at Sun and Earth L2, where the blue point is representing Earth and the moving pink point represents the spacecraft.
Major payloads. Visible Emission Line Coronagraph, VELC. The coronagraph creates an artificial total solar eclipse in space by blocking the sunlight by an occulter. The objectives are to study the diagnostic parameters of solar corona and dynamics and origin of coronal mass ejections. Additional objectives are to determine why the solar atmosphere is so hot, and how the changes in the Sun can affect space weather and Earth's climate. Solar Ultraviolet Imaging Telescope, SUIT. SUIT will observe the Sun between 200 to 400 nanometers wavelength range, and it will provide full disk images of different layers of the solar atmosphere by making use of 11 filters. The Sun has never been observed from space in this wavelength range. The spacecraft being at the first Lagrangian point, SUIT shall be observing the Sun continuously without interruption. Aditya Solar Wind Particle Experiment, Aspects. To study the variation and properties of the solar wind as well as its distribution and spectral characteristics. Solar Low Energy X-ray Spectrometer, SOLEX. To monitor the X-ray flares for studying the enigmatic coronal heating mechanism of the solar corona. Magnetometer. To measure the magnitude and nature of the interplanetary magnetic field.